In this video, I'm going to show you how to find node in a binary search tree. Before we get to the pseudocode, let me go ahead and set up this method, and it's going to be called find. It's going to be passed value as an argument. To get started, we're going to check if no value as an argument or root node doesn't exist. So if not value, meaning there is no value passed as an argument, or not this dot root, meaning there's no root node, then just return undefined. So that's our edge case. Next, set current variable equal to the root node. So to start off with, we're going to set our current node. Let's call it current and let that equal to this dot root. Next, set found variable equal to false by default. Let found equal to false. All right. Towards the end of our method, this will be the value of found will be returned, and it will be either true or false, letting us know whether the value did exist within our tree or not. Next, when a loop while found is equal to false and we have a current node. So loop while found, while not found and current node, and current like so, meaning we do have a current node at the moment and it's not null. So if those two conditions are met, we're going to enter the loop and we're going to check if value equal to current node's value, then set found to true. So if value is equivalent to current dot value, then that means that the value we are searching within our tree doesn't indeed exist. Therefore, set found to true. Next, if value is less than the current node's value, enter this block of code. Else if value is greater than the current node's value, enter this block of code. So if value is less than current dot value, then enter this block of code. Else if value is greater than current value, then enter this block of code. Now notice over here, instead of else if, we can just simply do else. Okay, we could do that. However, I'm doing else if because I feel it's more verbose and I want to be explicit as to what is happening. So that's optional. So over here, inside the if block, if value is less than the current node's value, then set current to be the current left's child. So we're gonna reset the current to now equal to current dot left. So now when it goes back again to restart the loop, the current variable will have a new value. And within the else if, the same thing, but we're setting the current to be the current's right child. So here, current will be equal to current dot right. And at the very end of the while loop, we're just going to return found, the value of found, which again will be either true or false. Now, I want to explain this portion here, the condition within our while loop. We have to have this current here in addition to this not found. Otherwise, if we just had the found, not found, then our loop will run into an infinite loop. So this current will help resolve this infinite loop. Now, this current, what happens is that whatever value we have passed as an argument, let's say we have this tree here, okay? We built out this tree and we have to start at the very top, right? The root node. And let's say as a value, we pass the value of, I don't know, let's say 1, okay? So we'll start over here and the code will be, is 1 less than 10? Yes, it is. So it's going to move to the left. Is 1 less than 7? Yes, it is. Then move to the left. Is 1 less than 3? Yes, it is. So move to the left. But now at this point, what's going to happen is that current has run to an end. So it will be set to null. Okay. So that's the conditional here, is we have to make sure that if it runs towards the end, if here or over here or over here, you know, we have to let the code know that we have run to an end. So set current equal to null. So that's what this block of code, our loop, is doing. So we are checking so long as not found and current does exist. Okay, so long as current is not null, in other words, then run this block of code. Okay, all right, so now our find method is complete. Now let's go ahead and test this out. I'm gonna go like this. I'm gonna expand our console. I'm gonna run this code and we get our binary tree here. All right, that is building out this tree here. So now within my console, what I'm going to do is I'm going to do tree.find, and I'm going to first check for, let's check for 10. It should be true. Look over here. It's true. Let's change that to, how about 12? It's true again. How about 9? It's true. All right, now let's test for something that doesn't exist. Let's say 22. It's false. False. Let's do 9 or 8. False. All right, now how about our edge case? Let's not even pass anything in. Look at that, undefined. And that's what we did over here as our edge case. It's returning undefined. Okay, so now we have a functional find method for searching a value within our tree.